Every dinosaur toy set you've ever seen, the plastic ones, the museum ones, the ones in every children's book about prehistoric life, almost all of them contain the same mistake. One animal that doesn't belong there. An animal that lived 40 million years before the first dinosaur ever existed. It's been in those sets for decades. Museums displayed it wrong. Textbooks got it wrong. And the reason nobody corrected it for so long is that the truth about what this animal actually was, where it actually sits in the history of life on Earth, is so unexpected that most people still haven't heard it. This animal is not related to dinosaurs. It's not even close. It is, by every measure modern genetics and paleontology can apply, more closely related to you, to every human being alive today, to every mammal on this planet. The dinosaur toy set has been lying to you your entire life. And the real story of this animal, how it lived, what it was, and why its lineage survived everything the Earth threw at it for 295 million years, is stranger than anything that plastic set ever suggested. This is Dimetrodon. Dimetrodon lived approximately 295 to 272 million years ago during the Permian period, which preceded the age of dinosaurs by roughly 40 million years. When it was alive, the continents were still joined into the supercontinent Pangaea, and the landscape of what is now North America and Europe was a hot, seasonal floodplain crossed by river systems and edged by dense forest. No birds, no flowers, no grass. A world that looked fundamentally different from anything alive today, inhabited by animals that don't fit neatly into any modern category. It was not a small animal. Adults reached lengths of around 11 to 15 feet depending on the species, and there were at least 13 distinct species of Dimetrodon, varying in size and proportion. It moved on 4 sprawling limbs, low to the ground, with a gait that was effective but not built for speed. What defined it, visually immediately, was the sail. Running along the full length of its back was a structure formed by elongated neural spines, some reaching nearly 4 feet in height on the largest individuals. The spines were connected by skin, forming a tall, thin sail that would have been impossible to miss. For most of the 20th century, the explanation was straightforward: thermoregulation. The sail as a solar panel, absorbing heat in the morning to warm the animal quickly, releasing it in the afternoon to prevent overheating. Mathematical models suggested a large sail could reduce the time needed to reach active body temperature from several hours to under an hour. In a world where most competitors were entirely dependent on ambient temperature, that was a significant advantage. More recent research has complicated this. Some studies suggest the sail's surface area is too small to produce the thermoregulatory effect the original models predicted. Other hypotheses point towards species recognition, or sexual selection. The sail as display, the way antlers function in modern deer. No single explanation has been established decisively. The sail was real. What it was for is still an open question. But the sail is not why Dimetrodon matters, not even close. Dimetrodon was the apex predator of its ecosystem, the top of the food chain in a world that had not yet produced anything resembling a dinosaur. Its prey included large amphibians, early reptiles, and fish. And its teeth, which are where the animal's name comes from, meaning 2 measures of teeth in Greek, were differentiated in a way that was genuinely novel for its time. Most animals in the Permian had simple, uniform teeth. Dimetrodon had 2 distinct types: long, sharp, canine-like teeth at the front of the jaw for puncturing and gripping, and smaller, serrated teeth further back for processing food. This differentiation, called heterodonty, is a feature shared by virtually every mammal alive today, including humans. It is not a feature shared by any dinosaur. The jaw itself was powerful. Bite force estimates based on skull geometry suggest Dimetrodon could generate enough pressure to crush bone in smaller prey. Fossilized bones recovered from Permian sites in Texas and Oklahoma show damage consistent with Dimetrodon feeding, puncture marks matching its tooth spacing, evidence of bone being consumed rather than discarded. This was an animal that processed its kills completely. In an environment where prey could be scarce and competitors numerous, nothing was wasted. It hunted alone, as far as the evidence suggests. No indication of pack behavior exists in the fossil record. For an apex predator of its size in that landscape, Solitary ambush along riverbanks and forest edges was sufficient. It didn't need help. Now here is the part that took science an embarrassingly long time to communicate to the rest of the world. Dimetrodon belongs to a group called synapsids. Synapsids are defined by a specific opening in the skull behind the eye socket, a single temporal fenestra that changes how jaw muscles attach and how powerful the bite can be. This feature appeared early in the history of amniotes, the group that includes all reptiles, birds, and mammals. Dinosaurs are diapsids. They have two such openings. The difference sounds minor. The evolutionary distance it represents is enormous. The synapsid lineage that Dimetrodon belongs to eventually produced the therapsids, increasingly mammal-like animals that dominated the Permian. The therapsids gave rise to the cynodonts. The cynodonts gave rise to the first true mammals, approximately 225 million years ago. That lineage continued unbroken through the entire age of dinosaurs and out the other side, eventually producing every mammal alive today. Dimetrodon sits near the base of that lineage. It is not your direct ancestor in a straight line. The path is long and branching, but it is on your side of the family tree in a way that no dinosaur ever was. A Tyrannosaurus rex is more closely related to a modern chicken than it is to you. Dimetrodon is more closely related to you than it is to any dinosaur that ever lived. That fact has been in the scientific literature for decades. It has not reached popular understanding. Every year, Dimetrodon appears in dinosaur toy sets. Every year it shows up in children's books about the Mesozoic, an era it preceded by tens of millions of years. Paleontologists have written about this specific misclassification as a case study in how scientific knowledge fails to travel from research papers to the people who should know it. The correction exists. The toy sets haven't changed. Dimetrodon went extinct approximately 272 million years ago, near the end of the Permian. It did not survive to see the first dinosaur. It did not survive to see the Permian Triassic extinction event, the largest mass extinction in Earth's history, which arrived roughly 20 million years after Dimetrodon had already disappeared. What it left behind was a lineage. The synapsid line continued after Dimetrodon was gone, producing more advanced animals, more mammal-like with each passing million years, moving towards something that would eventually, after two more mass extinctions and the entire age of dinosaurs, produce the animal processing these words right now. The sail is gone. The sprawling gait is gone. The Permian floodplains are gone. But the lineage that Dimetrodon belonged to did not go extinct. It is in your chest right now, in the form of differentiated teeth, a four-chambered heart, a jaw structure that traces back in an unbroken line to an animal in the red beds of Texas that the world spent a century calling a dinosaur. It wasn't. It was something far stranger than that. It was the beginning of a very long road that ended, among other places, here.